Okay, so let's take a look at continuous growth and decay. You'll see we have a formula that we go by. A of t equals A times e to the r times t. And that's kind of known as your generic formula. Continuous growth and decay will have many different applications. But for the example that we're doing right here, we're looking at it as a business application. So you'll notice we use it in the form of A of t equals P times e to the r times t. So we're just reminding ourselves what these all mean. P is the principal or the initial investment. So if we're looking at this particular example, we see that Andy invests $100,000. So off to the side, you'll see me kind of label what I think stands for each variable. So principal, $100,000 at a nominal 12% interest per year. So the percentage that I'm seeing with the 12%, we are looking at the continuous growth rate. So that will be my R. But notice whenever you have to enter it into your calculator, the 12% will be written as a decimal. So we move the decimal point 2 places to the left. So in our case, R will be 0.12. So we have P times e to the RT, and the last thing we need to do is identify who is our time. And in our case, they're asking what will be the value of the investment in 25 years. So in 25 years, that gives us T, 25 years. And I want to emphasize the reason why we are using this formula. With the E in it, we have the word compounded continuously. So that's a big heads up to use that. So if we're trying to figure out what will be the value of the investment in 25 years, all we're doing is we're plugging in for time. So T will be 25. So we're calculating the function evaluated at 25 years. So we'll plug in everything we know. So we have P is 100,000. And then we have E, that's our irrational Euler's number, to the R times T. So these are exponents. Let's see if I can write that a little bit larger for you. And T again is 25 years. Now notice we're going to have to use a calculator to help us figure this out because we don't know powers of E off the top of our head. Unless, of course, maybe it's E to the power of 1. If you haven't memorized, that's kind of cool. We see it right here. But really, we will need the use of our TI. And I would like to point out a lot of times we end up having a minor error based on what we call the exponent. Sometimes it'll be obvious to us, but I'll point that out in a second. But just keep in mind if you have maybe a TI-83 or if the TI-84 uses exponents to uses the caret key, I guess. The caret key, I don't know if you remember that, to represent exponents. You'll have to enclose your entire exponent expression inside extra set of parentheses. So that would look like, if I may, you probably would punch that in as 0.12. You'll use the multiplication sign, and we'll use the 25. And if I go a little backwards, that will leave us with the E. And then generally, we would have 100,000. And I'm kind of paranoid, so you kind of have me use another multiplication symbol, and that would be something that I would notice if I were maybe using the TI-83 or perhaps a TI-84 where it forces us to use the exponent key, or you see that in the screen. So having said all this, Let's switch over to our TI. And you'll see in this screen right here, I already have E punched in at the top just as a reminder. And I'm kind of reminding you that E it works kind of like the number pi, where it's irrational. So if we want to type in into the home screen, we would just type in 100,000. Just making sure you count your zeros. Multiplied by E. Now, if you want to get E on the calculator, it is right above the natural log key, which is right next to the number 4. It's to the left of the number 4. So we don't want to press the natural log key right away. You want to use the second function to get there. So second natural log, that will have the E call up on the TI. And now you'll see that my TI has a function where it shows the actual exponent in the exponent position. So it's a little nicer for us. So I will punch in the 0.12. And again, that's multiplied by 25. And so notice the exponents are both in the exponent position. If you forget, or if you have the older version and you don't make sure that you have a full exponent 0.12 times 25, you will end up with a different answer. So we press enter and we get ourselves an answer. And so we have to understand what that really means. That's quite a bit of money. Let's switch back to this screen, and we will remind ourselves what that rounds to. We have approximation going on, so let me write down exactly what I see in the TI. I have 200 8553. And because we have money, we really do care about the decimal point. So I'm looking at 0.692. But my friends, if we're speaking about real life, as far as decimal points are concerned, you round to the nearest hundredth because you're looking at the nearest penny. So if you're rounding to the nearest hundredth, you're looking at the digit in the hundredth place, looking at the test digit 2, and that's telling us we're going to keep it at the 9. So we'll have approximately, or in terms of money, 200. Oh, actually, I should be a little more precise with my commas. Let's work backwards. And I'll move this over here. Our TI-83 work just to remind ourselves. We'll put this over here on the side. But if we're going to say this out loud, I believe if I'm using the commas to represent the periods of all the numbers, if you invest $100,000 and you have a clear 12% interest per year, you end up with final amount in your account, $2,008,553.69. So not bad. So I hope this helps, gives you an idea of how to use E in your calculator. If you're using a different calculator, you may want to check with the tutor to see how that works. But for the TIs, these are all pretty much the same. And just kind of pay attention if you do have a TI-83, pay attention to using the exponents all in one place. I'll see you in the next example.